Hello, you're welcome to our presentation, International Power Outages, Implications for Nigerian Power Systems. The outline here will guide the presentation. 1. Power outage events, system collapses in Nigeria, sample global major outage events, case study, Indian power outage experience, case study, United Kingdom power outage experience, regulatory imperative of power outage management, conclusion, and expected learning experience. By way of introduction, power outage events is always here with us, and electricity is a critical infrastructure for social and economic development, and its failure can arise on account of the following: transmission failure, faults of various forms and degrees can bring about transmission failure, vandal activities, collapse of transmission towers due to erosion encroachment, transmission line components failure are all factors that can give rise to transmission failure and ultimately a power outage. Secondly, lightning strike. Lightning strike on an active transmission line can bring about transient disturbance on the power flow and stability of the system. Protective devices may not respond timeously to such transient disturbances, hence giving rise to trip operation that can throw the system into blackout. Where such exists, a power outage has taken place. Thirdly, generation inadequacy. Overload situation can arise when the power delivery through the transmission line is inadequate for the demand. Protective schemes will operate to relieve the system of overload. Equipment failure or malfunctioning. Failure of equipment in service due to faults, fire outbreak, maloperation can lead to power outage. If not isolated on time, will create more devastating consequences for the system. In the present slide, we have the geographical map of Nigerian transmission network. The grid is essentially made up of 330 kV and 132 kV network with associated power stations and substations. Table 1 is the statistical data of both partial and total system collapse on Nigerian power grid from the year 2000 to the year 2019. It shows a gradual decline on the number of occurrence of system failures over the period under review. Again, Table 2 is a sample global measure blackout events. Different events account for the power outage at different locations. As it can be seen clearly, there are different forms of events that can lead to blackout, from transmission failure, tree trimming, lightning, and all the rest. This is only a sample of few world events that had a devastating power outage at a global scale. Case study of an Indian experience of power outage that took place on 30 to 31st July 2012. On this day, India suffered a major blackout event. Investigation was carried out to determine the following: the precondition of the network prior to the outage, the initiating events, the cascade events if any, the final restoration of power supply to the affected area, and identify new challenges to a sustainable power system. At the end, investigation revealed that there was inadequate power supply with respect to demand. The network interconnections between the northern region and western region of Uttar Pradesh were out of supply due to scheduled and forced outages at the time of the disturbance. The only remaining link between the northern region and western region is the 400 kV Binagwale Agra, which became overloaded. The Regional Load Dispatch Center initiated load shedding and directed Western Region to reduce generation to curb the power flow, but the response was not quite enough. It didn't come at the time it was expected. There was appreciable current flow through the line, and inadequate reactive power compensation gave rise to reduced voltage profile. This condition was sensed as fault by distance relay and therefore actuated trip action on the transmission line. Following the tripping of the 400 kV line, power to the northern region was routed through the eastern region. The new path, western region to eastern region to northern region, is much longer than the previous one. This gave rise to larger angular separation between group of machines in western region and northern region. This can be understood better from a simple power angle equation as shown. Also, sine being an increasing function, transfer of equal amount of power between 2 points with increased transfer reactance, the value of data has to go up. This implies that the rotors of the northern region machines will further fall behind the rotors in the western region machines. This gave rise to a phenomenon known as power swings, and impedance relays could not differentiate between power swing and a fault condition, hence initiating a trip action. The northern region was generating less than its demand, so its frequency drops and went into blackout due to operation of under-frequency relays. Due to loss of northern region, the eastern region and western region were left with a surplus generation, and the frequency in this region shot up. This also caused a few of the west region generating units to shut down, thereby causing the grid to be separated into two islands, the northern region and the eastern region, with one island, eastern region surviving and the other northern region collapsing. About 600 million electricity users were affected by the power outage. In the case of UK experience, on this day, 9th of August 2019, United Kingdom suffered a major power outage that threw about 1.1 million electricity users into blackout. The electricity regulator ordered a large-scale investigation, and here are some takeaways from the investigation report. 1. There was a lightning strike on the transmission network north of London, the 18-second Waimanley main, at about 16:52 hours. About 500 megawatts of generation were lost in the first instance from embedded distributed generation. This is closely followed in seconds by a drastic reduction in output by Hornsey Offshore Wind Farm and Little Baffer Gas Plant Station. About 1,378 megawatts was lost. The sudden loss of generation gave rise to a frequency falling quickly and went outside the normal frequency range of 50.5 Hz to 49.5 Hz. Under the Regulatory Approved Security and Quality Supply Standards (SQSS), the Electricity System Operator (ESO) has 1 gigawatt automatic backup power to maintain grid integrity. However, all the backup power and tools ESO deployed to manage the frequency, including 472 megawatts of battery storage, could not stabilize the frequency, which went further down to 48.8 Hz. The secondary backup system, through the Low Frequency Demand Disconnection (LFDD) scheme, responded by disconnecting some demand to stabilize the frequency. The action of LFDD put about 5%, that's 1.1 million electricity users of Great Britain, in blackout, representing about 1 gigawatt, to protect the other 95%. The action of the FDD, backed by dispatch of additional generation, returned the system to normalcy. Disconnected customers were fully reconnected back to supply by the distribution network operators by 5:37 p.m. In all, the whole event lasted for about 45 minutes for full power restoration to be achieved. The regulatory imperative in power outage management. Office of Gas and Electricity Markets (Ofgem) is the regulator in the UK power system network. The regulator, after analyzing the full report of their investigation, found the energy firms culpable. They are Ørsted, owner of Hornsea Offshore Wind Farm; RWE, owner of Little Bafford Combined Cycle Gas Plant; UKPN, distribution network operator. They reconnected the customers to the grid without obtaining clearance from the grid operators following the disturbance in the network. As a result, a total fine of £10.5 million was imposed on the 3 energy firms for the observed operational infractions. Conclusion / expected learning experience. The management of Nigeria's power system have so much to learn from experiences of international power outages. Essentially, investigation helps to have an insight as to the precondition of the network, the initiating events, the cascade events, final restoration of power supply, identify new challenges to sustainable power system, impose appropriate sanctions to area energy firms found failing in his responsibilities. Having said that, there is so much to gain by Nigeria in the management of power outages as experienced in other climes. First, there is need to commission thorough and detailed investigation into any major failure event in the power system. 2. Review the National Electricity Plan to make investment attractive in the sector. Segregation of the power system grid in Nigeria into regional networks. Strengthen the regulatory institution to be genuinely independent. The regulatory institution should play the role of an independent arbiter, discharging its duties without undue influence and bias. This will make the operators always conscious of their responsibilities and also evolve new ways of efficient power delivery and service. Furthermore, procure adequate spinning reserve to respond to generation emergencies and encourage integration of energy mix through application of microgrids. evolve and review periodically the relevant regulatory frameworks, standards and policies to guide grid system management. Adopt effective system data and information coordination to monitor, control and manage power flows under normal and abnormal circumstances. Adopt futuristic approach in the simulation and evaluation of the operation of the power system network and equipment reliability towards the development of effective protection for the power system network. Thanks so much for listening. Bye.